This video is about congruency proofs. So for these first few problems, if the triangles cannot be proven congruent, do not fill anything in the blanks. You leave these blank and circle we cannot prove they are congruent. So if we are given that FD is congruent to BC, so that's FD is congruent to BC, ED is congruent to AC, so there's ED and AC, and angle F is congruent to angle B. So here's angle F and here's angle B. I have two sides, but the angle is not between them. If there were such a rule, this would be side-side angle. But no, there is no such rule. Side-side angle cannot prove that two triangles are congruent, so we will circle we cannot prove they are congruent, and we will not fill anything in here. All right, if you try to make a congruent statement with the triangles, you will get the problem wrong. All right, moving on to B. FD is congruent to BC. So here's FD and here's BC. Now ED is congruent to AC. So ED is congruent to AC. Angle F and angle B are right angles. So here's angle F and here's angle B, and they are right angles. Now, as we saw in the previous problem, if these were not right angles, it would be side-side angle, and they cannot be proven congruent. But there is a special rule that we can use for right triangles, and that is hypotenuse leg, abbreviated HL. And that's exactly what we have here. The hypotenuse and a leg is congruent to the hypotenuse and a leg. So triangle ABC will be congruent to the other triangle. The order matters, so if I do ABC, then I'll have to do EFD. Okay, EFD. All right, for this problem, we are given that angle B is congruent to angle D. So here's angle B and here's angle D. And we are given that A is the midpoint of BD. If A is the midpoint of BD, that means that this segment and this segment will have to be congruent because A is right in the middle. And in addition to that, we have the vertical angles, which are always equal. So these are vertical angles right here, so those are going to be congruent. So these triangles will be congruent by angle, side, angle. All right, two angles and the side in the middle, that's going to be angle, side, angle. So let's see, triangle ABC is congruent to triangle what? Well, obviously, the two angles at A are corresponding angles. So where I see A, I'm going to put A. And then let's see, for B, I notice the single mark, and that corresponds to angle D. All right, and that just leaves angle E. All right, the order has to be the same. These have to be corresponding angles. All right, moving on. Okay, angle B is congruent to angle D is given. A is the midpoint of CE. Okay, so A is the midpoint of CE. So CE is running this way, so that means this segment will be congruent to that segment. Again, we have our vertical angles, which are always congruent. Okay, So this is angle, angle, side. I have two angles, but the side is not between them. So we call this angle, angle, side. So the triangles are congruent. So triangle ABC is congruent to triangle ADE. Okay. AB bisects DAC. So look, angle DAC is this angle over here, DAC. And AB bisects this angle. Bisect means cut in half. So this is AB. AB comes along and splits that first angle in half. So it creates two congruent angles, two halves. So these are the two angles that have to be congruent to each other. Okay. We're also given that DB is congruent to CB. So here's DB, and here is CB. And we also know that the shared side, of course, will be congruent for both triangles. So I'll just mark that like this. So, if it were a thing, these triangles would be congruent by side-side angle. But again, we know that side-side angle does not prove that triangles are congruent. So we're going to go ahead and circle we can't prove they are congruent. And we will very carefully leave this 100% blank. Okay. AB bisects DBC. So look at the angle that is being bisected. This is the angle that we are cutting in half. So DBC. So DBC is the angle that is being bisected. And here is segment AB that comes along and splits this angle in half. So this angle will be split into two congruent parts, and these are the parts that will be congruent. Now, DB is congruent to CB. So here is DB, and here is CB. And then there's the shared side. Now this will be side, angle, side. We have the two sides and the angle in the middle. So these two triangles will be congruent by side, angle, side. Okay? So now we can make the congruent statement. So triangle ABC, all right, will be congruent to triangle. Now, these triangles are not, sometimes these triangles are flipped backwards. And we'll have one mark at B, and then the other mark will be at A, like they'll be backwards. And then I have to be really careful to reverse these. But that's not the case. Both angles are marked here at B, and I have both blank angles at A. So A is going to correspond to A in both triangles. Okay, and then B is going to correspond with B in both triangles. And then, of course, the C will correspond with D in the other triangle. All right, but sometimes they flip backwards, so be careful, watch out. Okay, DA is parallel to BC. When you have parallel lines, that will lead to congruent angles, either alternate interior angles or corresponding angles. So you have to be careful and highlight the parallel lines to begin. So DA is parallel to BC. So these are parallel. Okay, now I'm going to go ahead and highlight the transversal, the diagonal. The Z shows me where the alternate interior angles are. All right, the corners of the Z will be congruent if these lines are parallel. So those are the angles that will be congruent. Those are alternate interior angles. And we are also given that DB is congruent to AC. And then, of course, we have the shared side. So here we go again. This would be side angle. We have two sides and the angle that's not in between them. But as we've said twice before, side angle does not prove triangles are congruent. So we are going to go ahead and circle, we can't prove they're congruent. And whatever you do, do not fill these in. Leave both blank. Okay, so here comes a similar problem. DB is parallel to AC. Okay, is that the same exact problem? No. Last time, the top and the bottom were parallel. This time, we have DB, and that's parallel to AC. So when I draw the transversal, the diagonal, the corners of the Z are here and here. So these are those alternate interior angles that will be congruent. Let's see how that changes things. Now, DB is congruent to AC. So there's DB and there's AC. And then there's the shared side. This time we have two sides and the angle in the middle. That makes this a side angle side situation. So these two triangles will be congruent. Now, many students will often write the congruent statement in the wrong order because notice how these triangles are backwards. See this mark down here at B, but in the other triangle, it's up here at A. So angle B in the top triangle corresponds with angle A in the bottom triangle. See, it's backwards. So, angle A, all right, so the lower triangle is triangle ABC. So angle A in the lower triangle corresponds with angle B in the upper triangle. Okay? So don't automatically go, well, A will correspond to A. No, A corresponds with B. And then we have angle B in the lower triangle will correspond with angle A in the upper triangle. All right, see how it's blank and blank. So B will correspond with angle A. All right, so when these are flipped backwards, then these get flipped backwards. And then, of course, that leaves angle C to correspond with angle D. That part's obvious. So this has to be the order, triangle BAD. A lot of students will have these backwards. All right, so we're moving on to problem number 2, and we'll be doing this A, B, C, and D. But the next several problems are under problem number 2. So we are given that AC is congruent to DC, and they already marked that for us, but I'm going to mark it myself. B is the midpoint of AD. So here's AD. So if B is the midpoint, then that means that DB is going to be congruent to BA. Okay, then we also know that the shared side will be the same for both triangles. So I see side, side, side. So that does prove that the triangles are congruent. So triangle ABC, so ABC, so that'll be DBC. Okay, given AC is congruent to DC. So again, here's AC and here's DC. BC bisects angle DCA. Okay, we're bisecting now. So angle DCA is the angle that's being split in half. So here is angle DCA. So see this, I've got this whole angle right here. All right, that's angle DCA. But BC comes along and bisects it. BC comes along and splits it in half. And that creates two congruent angles. All right, so I'm going to have that. I also can know that the shared side is going to be the same for both triangles. So that gives me a side angle side situation. Two sides and the angle in between. So side angle side proves that the triangles are congruent. So let's see. I have triangle ABC, and that'll be DBC. Okay, AC is congruent to DC. Boom and boom. AD is perpendicular to BC. Okay, so AD is perpendicular to BC, which means that these are right angles. Okay, 90 degrees. And then we also have the shared side that we can mark as congruent for both triangles. That gives me two sides and an angle that's not between them, which if these were not right angles, that would be side-side angle, and I'd have to circle we can't prove they are congruent. But because they are right angles, that makes this a hypotenuse and a leg. So we can use the hypotenuse leg theorem. So once again, the triangles are congruent. So ABC, DBC. Okay, AC is congruent to DC. Angle A is congruent to angle D. There's angle A, and there's angle D. And then there's the shared side. Kabam! Yep, this is what I warned you about on the previous problem. We have two sides and the angle that is not in the middle. So that would be side-side angle, which is bad. Boo! Side-side angle can't prove that triangles are congruent. So we will circle this. And we will not write a congruent triangle statement right here. Leave both of these blank or the problem is wrong. Okay, we're switching gears, so let me zoom out. We are given that triangle PQR is congruent to triangle STU. And they're giving us some expressions for PQ, QR, TU, and US. Circle the pair of lengths that must be the same. So just using the order of the letters. All right, let me zoom back in for a second. Using the order of the letters, we don't even have to draw a picture to know the segments that should be congruent. For example, PQ should be congruent to ST. Okay, maybe I'll just make a little list here. PQ should equal ST. Okay, similarly, QR should equal TU. So QR should equal TU. And one more time, people. PR should equal SU. PR should equal SU, just by the order of the letters. Okay, so let's see. We're supposed to circle a pair of lengths that must be the same. So PQ and ST, I see PQ, there is no ST here. QR and TU, okay, there they are. So QR and TU, those are the two that must be the same. But here's a complete list right here. So now let's find the value of x. Well, let's start by looking at the expressions that they gave us, and let's match up any that we can. So PQ is congruent to ST. Well, I guess maybe they gave us, yeah, so these four segments are the same four expressions that they gave us. So we just decided that QR is congruent to TU. All right, so let's highlight those. So QR and TU, those should be the same. So I'm going to have to pick that pair in order to make an equation. So that's what I'm going to do. So because QR equals TU, that means that 8x minus 4 is going to equal 7x plus 1. So now we need to solve this equation. So if I subtract 7x from both sides, then that's going to give me x minus 4 is equal to 1. And then if I add 4 to both sides, that's going to give me x is equal to 5. Okay, so, all right, that was one of the things I was supposed to do, so fine. I know that x is equal to 5. Okay, so now I should be able to start finding a bunch of expressions. So might as well start with QR. So QR is 8x minus 4. If x is 5, that means that QR is equal to 8 times 5 minus 4. Okay, so that means that QR is 40 minus 4, so QR is 36. Okay, so I can go ahead and fill that in. QR is 36. All right, we also know that QR and TU are equal. So I can go ahead and put 36 for TU as well. Okay, next I can find PQ. All right, because I have the expression. So PQ equals 5x plus 7. All right, and x is 5. So that means that PQ is going to equal 5 times 5 plus 7. So that's 25 plus 7. So that's 32. So PQ is 32. Okay. Let's see. PQ is 32, but we know that PQ should equal ST. So if I see ST somewhere, I can also put down 32 for that as well. Okay, and then I come to US. So US is equal to 6x. So of course that means 6 times 5. So US is 30. So US is 30. Okay, US is the same as SU, and that should be the same as PR. Okay, so that's why I can also put 30 for PR.
Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.